Okay, so in this video tutorial, we are going to discuss the law of sines, or we are going to solve oblique triangles. We're done with solving right triangles. So we are now going to apply this particular law, which is the law of sines, in solving triangles which are not right angled. So they are not right triangles. Now, what is the law of sines? Alright, so the law of sines is also what we call as the sine rule. And as I've mentioned, we use the law of sines in solving oblique triangles or non-right angled triangles. Now, if we are given with a triangle similar to this one, and we are asked whether or not this is right angled. So, if this triangle that is given here is a right angle, so therefore, the way to solve this right triangle when we solve for the missing angles and the missing sides is simply to use the SOHCAHTOA as what we have previously discussed. So that is SOHCAHTOA. Okay, now if this triangle that is given is not a right triangle or not right angled or simply oblique triangle, we are not going to use the SOHCAHTOA because the SOHCAHTOA is only applicable to right triangles. We are going to use a particular law. Okay, so this is the law of sines. And also, another one is we are also going to consider the law of cosines. But for this video tutorial, we are just going to focus first on the law of sines and how we're going to apply this law to solve the missing angles and missing sides of oblique triangles. Alright, so what does the law of sines tell us? So, the law of sines tell us the relationship about the sine of the angles and also with relation to its side. So, say for example, if I'm going to draw an oblique triangle and we name this triangle as triangle ABC, alright, we are going to consider the opposite side from the angle. So, if we have angle A, we know that the opposite side of angle A will be side A. So, we're going to designate that as side A. Now, if we have angle B, alright, so angle B, the opposite side of angle B will be side B. So, small letter B. And also, if we have the third angle, which is angle C, the opposite side of angle C will be side C. Okay, so we designate capital letters for all of the angles and small letters for the sides opposite those angles. So in this case, because we have capital letters A, B, and C, so our sides which are opposite the angles will be small letters A, B, and C. Now, what does the law of sine tell us? So the law of sine tell us that we have sine of angle A over side A will be equal to sine of angle B over side B, and that is also equal to the sine of angle C over side C. Now, we can also express this in terms of the reciprocal. Okay, so whichever you use will yield to the same result. So, this can also be expressed as side A over the sine of angle A is equal to side B over the sine of angle B equals side C over the sine of angle C. Alright? So, that is how we illustrate the law of sines. And we're going to apply this to solve for the missing angle and the missing sides. Now, let's begin with this example. Okay, let's just complete the given. So, we have angle A, which is 30 degrees. We have angle B, which is 45 degrees. And suppose that BC has 2 units. Okay, so the measurement of BC is 2 units. Now, in this particular example, we are only given with 2 angles and a side. Now, we are required to find the measure of angle C and also the remaining sides. Okay, so what are we going to do? So the first thing that we're going to do, it's very easy to solve for the missing angle because we are given already with two angles. So we know for a fact that the sum of the angles of a triangle is 180 degrees. So let's begin with solving for angle C. So that will be measure of angle C is simply equal to 180 degrees then minus the sum of the two. So that will be 30 degrees plus 45 degrees. So this is equal to 180 degrees minus 30 plus 45 degrees is 75 degrees. So 180 degrees minus 75 degrees is 105 degrees. So we're done with the measure of angle C. Okay, with 105 degrees. So let's just label this with 105 degrees. Alright, so by the way, the illustration is not drawn to scale. Alright, so next, we're going to solve for the missing sides. Now, let's write first the formula. So that is side A over sine of angle B. I mean, that would be A over sine A. Alright, so let's just correct that. Equals side B over sine B, angle B, that is equal to C over sine of angle C. Okay, now, the next thing to do is to substitute all of the given values. Now, let's label. This is angle A, so of course, the opposite of angle A will be side A. So, this 2 is our side A. So, this will be 2 over sine 30 degrees. So, that is equal to side B. So, we don't have a value for B. So, let's just stay B over sine of 45 degrees. Then equals, so C, alright, opposite of angle C. So, that will be C over, we have sine of 105 degrees. Now, we can solve for the missing sides because we have a multiplying factor, or we have a factor that can be multiplied to the missing, okay, to what is missing there, so that we could be able to solve for it. So in this case, we have 2 over sine 30, which is a factor, multiplying factor, that we can multiply to both of these. So we have B over sine 45 degrees and C over sine 105 degrees. So one by one, let's solve. So 2 over sine 30 degrees will be equal to B over sine 45 degrees. Alright, so let's just cross multiply. So this will become 2 sine 45 degrees equals B sine 30 degrees. Okay, but we are only concerned about B. So we divide this by sine 30 degrees. Okay, so divide both sides by sine 30 degrees. Okay, let's just cancel. So, we just input these values in our calculator so that we can be able to get the value of B. So, input 2 sine 45 degrees over sine 30 degrees. And then, round off our answers to 2 decimal places. So, our answer here is 2.83. Alright? So, the value of B here now is 2.83. Now, let's solve for the value of C. So, we have our factor there. So, our multiplying factor. Okay? So, let's just equate the two. So, we have 2 over sine 30 degrees equals C over sine 105 degrees. Okay, let's just again cross multiply. So this will become 2 sine 105 degrees equals C sine 30 degrees. So we divide again both sides by sine 30 degrees. Okay, so what remains is C. So let's again input that in our calculator. So we have 2 sine 105 degrees over sine 30 degrees. Alright, and our answer is 3.86. So the value of C is 3.86. And we're now complete with the missing angle and the missing side of this triangle.